Do a couple examples working with vectors. So we're given three vectors A, B, and C in their component forms, and they're just, well, one is one-dimensional, the other have two dimensions. If they were three-dimensional vectors, you just have another component, and that component would be multiplying a z hat using Cartesian coordinates. Out of those three vectors, we want to do one operation, take vectors A and B and add them together to make a new vector, D, and we want to compute how long that vector D is, what its magnitude is, what direction it points. So this is an example of using the algebraic approach, where you break vectors down into their components. And then we use a graphical method to compute the vector E. E is the sum of vectors A, B, and C. So graphical method means we're going to use a ruler and a protractor. Ruler to measure the length of the vector E on a scale, and the protractor to measure the direction that it points. The first thing I'm going to do is just plot those three vectors A, B, and C in a Cartesian coordinate system so you can see what direction they point. So vector A is mostly down and then a bit to the right. Vector B is going to be mostly up and a bit to the left. And vector C has only one component, so it's 2 units to the right. The first thing we're asked for is calculating the vector D, that is the sum of A plus B. So let's go and get started on that. And A and B are already in components, so I can just add them together component-wise. So A, its x component is going to be plus 1. B, its x component is minus root 2. So along the x direction, I'm going to have 1 minus root 2 x hat. Along the y direction, A is minus 2, B is plus 3. So 3 minus 2 is 1. So it's going to have a y component of plus 1. So it's plus 1 y hat. We want to find the magnitude of this vector D. So writing that out, the magnitude, so D without the vector symbol, means I'm taking the length of the vector, and that means I'm using the Pythagorean theorem. So I'm going to take the x component of D squared, the y component of D squared, add those together, take the square root. So that means x component 1 minus root 2 quantity squared. The y component is just 1 squared. And I need to take the square root. So I expand out that term. I'm going to have 1 squared is going to give me a 1. Square root of 2 squared is going to give me a 2. And the cross term is going to give me a minus 2 root 2. I'm adding 1 from the other. The y component, and that is let me calculate that out, a magnitude of 1.08. And then what direction does D point? take the arctangent of the y component over, basically D is going to point pretty close to a long part of B, but it's going to be not quite as long. So we expect it to be there in the second quadrant. I could do this in terms of a x component and a y component to get that angle. And so y component over x component can be 1, and this 1 minus root 2 is 0.41, and you calculate that out, you get 67.7 degrees, and that is the angle clockwise from the negative x-axis. So that's basically saying it's this angle. Conventionally, what we use in physics is a counterclockwise rotation is a positive rotation and measured from the x-axis. So if this is 67.7 degrees, then the angle phi would be 112.3. And then there's the angle phi. All right. The other part we were asked to do is graphical calculation of a vector E, where the vector E is equal to A plus B plus C. So let me step through how to do that, and we'll use our diagram. So what we're trying to do for the second part is calculate the vector E, where E is equal to A plus B plus C. Vector addition is going to commute, so it doesn't matter what order I add those in together. And looking at the diagram, what I actually want to do is start with a vector B. I want to add the vector C to it, so I put the tail of vector C at the head of vector B. Just make sure it keeps the same direction and the same magnitude. So if I change the length or the direction, I have a new vector. And to complete the sum, I'm going to put vector A, the tail of it, at the head of vector C. So there's my vector C. Add in vector A. And then the sum, B plus C plus A, is going to be our vector E. And it's going to point in the first quadrant. It goes from the tail of the first to the head of the last vector in that sum. And if everything is drawn out fairly carefully, measured off with a ruler, the magnitude of vector E, when I did that, is about 2.3 units on that scale, and then with a protractor the angle I got to be, oops, sorry, 19 degrees. And that's measured counterclockwise from x-axis.